All right, today we're taking 7.6 through 7.8 review notes to help us for our quiz on Monday. First thing you're going to have to know are these signs, okay? Greater than. I want you to pull out your red pen and go ahead and write down what the greater than symbol looks like. Directly underneath it is going to be your less than symbol, which is the opposite way. And then remember your greater than or equal to, it looks exactly the same. It's just got an equal sign underneath it, or part of one. And then this is your less than or equal to sign. Once again, please make sure you can identify these symbols because there will be a full section where you're just writing in the symbols kind of like this on your quiz. We talked about this the other day. What is the domain, my x or my y? It is my x. What is my range? Y. Now, one thing you're going to have to know, when graphing inequalities, you have to flip the symbol when you're doing what? Not adding or subtracting. When you multiply or divide by a negative number on both sides. Number 1, tell whether the value of m is a solution to the inequality. What does that inequality say?
M is less than or equal to 6.
Okay, this is a less than or equal to 6. So let's go ahead and write that inequality to start with.
Yes.
What am I going to plug in for my m?
6. Negative 6.
Negative 6. Remember, if it's a negative there, make sure you're putting it in as a negative. Deasia, is negative 6 less than or equal to 6? Yes, it is. So yes, it is a solution to that inequality. Number 2, make an input-output table using 1, 2, and 3 for the domain, and then state the range. How many numbers did it give me for the domain? 3. So let's rewrite y equals negative 4x 3 times. All right, now for my input-output table, I'm going to need to put an x and a y. Tell me one more time, is the domain my x or my y?
X.
It is my x. So what are my 3 domains?
1, 2, and 3.
1, 2, and 3. Now what do I need to do?
Plug in the numbers, switch out the out for x.
Okay, plug it in for that x. So what does it mean when there's a number next to a letter?
Multiply.
Multiply. So I'm going to multiply this by 1, by 2, and by 3. All you're doing is you're taking this and plugging it into what would have been that x. Look at the first one, just the girls. What is negative 4 times 1?
Negative 4.
Negative 4. Just the boys. What is negative 4 times 2?
Negative 8.
Negative 8. And the last one, what is negative 4 times 3?
Negative 12.
Negative 12. At this point, you have officially created your input-output table. All you need to do is put a box around it. Next part, solve the inequality and then graph the solution. First thing, identify the variable. D. What is not allowing D to be by itself? Minus 3. What's the opposite of minus 3?
Plus 3.
Plus 3. What you do to one side?
Must do to the other side.
So this cancels out. The D comes down. What does that inequality symbol say?
Less than or equal to.
Less than or equal to. And what's 4 plus 3? 7. Do I need to flip the symbol?
No.
No. When do I flip the symbol?
When you multiply or divide by a negative number.
When I multiply or divide both sides by a negative number. Since I didn't do that, this is my correct answer. Now I am going to graph this inequality. How many points are on our graph?
3.
Only 3 points. What number should go in the middle?
7.
Good job, because whatever that number is right there is always going straight to the middle. What's 1 less than 7?
6.
And 1 bigger?
8.
Okay, so remember, this is looking just like a number line. Starts smaller on the left side, gets bigger on the right side. Is this an open or a closed circle? Why is it a closed circle?
Because it's equal to.
Because it's equal to. So what that simply says is 7 could be right there. 7 is less than or equal to 7 because it equals 7. Which other number would make this statement truthful? 6. So you're telling me this way, 6 is less than or equal to 7.
Yes.
All right, I want you to try problem B on your own. Problem B. A lot of you did get the correct answer, but let's check through who did not, okay? What is not allowing the variable to be alone?
Multiplied by 7.
Multiply by negative 3. What is the opposite of multiply by negative 3? Okay, you've got to divide both sides by negative 3. Now you are left with x is less than negative 6. Who would say this is the answer that you got? All right. Can someone explain to me why this should not be my final answer? Hannah. Okay, right here, I divided both sides by a negative number, so what do I have to do?
Turn to a positive.
Flip the number.
You flip the symbol. You do not turn it to a positive, you have to flip your symbol. Then that is your answer. Okay? A few of you are forgetting to box in that answer. Go ahead and box it in for me. Then what you want to do is graph it. Middle number?
Negative 6.
What's less than negative 6?
Negative 5. No, negative 7.
And what's bigger?
Negative 5.
Open circle or closed?
Open.
Which number makes this a true solution?
Negative 5.
Negative 5 is greater than negative 7. And then remember, you can always double check your symbol. This looks like a greater than symbol. This is a greater than symbol. Remember, you want these two to be the same as each other, not necessarily the same as that one up there. Okay, any questions on that one? All right, next part. This one's a little bit more difficult because it is a two-step equation, all right? There are two things that are not allowing the variable to be alone. What are those two things?
Negative 13 and 2.
Multiply by 2 and minus 13. According to our flipped classroom notes from 7.5, what do you do first every time? Add and subtract or multiply and divide? You always add and subtract. Remember how we've talked about it. This is the number that's attached to the variable. They're best friends. They want to stay together as long as possible. I want you guys to try this one on your own. What do I have to do first?
Add 13 into negative 2.
Add 13 to both sides.
Yeah.
And you're left with 2b is greater than 22. Now what?
Divide by 2.
Divide by 2. And you're left with what?
B equals 11. B is greater than.
Okay. Be careful to say it's greater than, not equal to, because that totally changes things. This is telling you any solution or any answer that's bigger than an 11 is correct. It is not equal to an 11. Okay, so be careful with that. Do I need to flip my symbol?
No.
No, why not?
Because you didn't divide or multiply by negative.
I did not multiply or divide by a negative number. So now we just got to graph this. What are my three numbers I should put?
10, 11, 12.
10, 11, and 12. Is this an open or closed symbol? Why is it open?
Because it has no.
There's no equal sign there, okay? So that's saying number 11 could not fit up there. 11 is not greater than 11, so that's why we don't have a dot on number 11. What is greater than 11?
12.
12. Any solution bigger than an 11 is the correct answer, okay? Does anyone need help or not understand what we just did? This one says, tell whether the graph represents a function of x. If it does, tell whether the function is linear or nonlinear. How can I tell if something's a function?
By doing the vertical line test.
By doing the vertical line test, okay? So remember, that's anything that goes up and down. How many times is it allowed to touch in order to pass the test? Only one time. How many times did this pass? It hit it there and it hit it there, okay? So is this a function? No, this is not a function, okay? If you remember, we said it can only be a function if for every input there's only one output. But if you look, if I input a -1 right there, then I am getting two outputs. So I can tell this is not going to be a function. All right, now if it's not a function, you don't have to tell me if it's linear or nonlinear. Let's go to the next one. Remember, you can do your vertical line test anywhere you want, to the left or the right of the y-axis. How many times did I hit my graph?
Once.
One time. So is it a function or not a function? It is a function. And Gavin, is this linear or nonlinear? How can you tell? It only hits it once. That tells me it's a function, but how can I tell if it's linear or nonlinear? It's a line, okay? So just like you see right here, you can see the word line in linear. That's just telling me that it is a line. Let's go on to the next one. Stephen, If you do the vertical line test, how many times does it hit your line? Only one time. So is it a function or no?
Yes, it is.
It is a function. Pearson, is this linear or nonlinear? Why is it nonlinear?
Because it's not a straight line.
You are correct. If it's not a straight line, then it is nonlinear, or, as you can see here, no line. It's not a straight line. Okay, any questions on that section? All right, we're going to go ahead and move on to our final question of the day. Graph the function, use -1, 0, and 1 as the domain. How many domains did it give to me?
3.
3 of them. So we want to go ahead and plug in 3 different functions. The next thing that you want to do is go ahead and make your input-output table. What is my domain going to be? -1, 0, and 1. Now, we know that we have to get rid of this x right here, and in place, we're going to go ahead and put a -1. Now look, this looks kind of tricky, so I'm just going to stick some parentheses around that, then stick in the 1, or the 0 and the 1. Let's talk about this right here. -1. What does that mean?
Double negative.
It's a double negative, which becomes a what?
Positive.
So, now I have +1 minus 4. Same sign, add and keep, different signs, subtract the numbers and take the sign of the larger number. So what's my answer?
-3.
-3 is correct. Next up, this says -0. We know that 0 can't be negative, so it just means 0 minus 4. Stephen, what's the answer? -4. Micah, what is -1 minus 4? -5. Notice right here, there is a pattern. Each one, I'm decreasing by 1. Okay, so if your numbers look really funny in your range or in your y, then you might know something went wrong, okay? So this is my input-output table. From this, I can easily get my ordered pair. What is the first ordered pair? Girls, what's the next one?
0 and -4.
Boys, what's the final one?
1 and -5.
All right, how many of you were able to at least get these 3 ordered pairs? Okay, now we're going to move on and we're going to go ahead and make our graph. All right, the first thing that I want to do is -1 and -3. Who'd like to come to the board to show me where it goes? Deasia, come on up. All right, guys, where should she start?
And the origin.
At the origin, 0, 0. Then, does she go left and right first or up and down?
Left and right.
Left and right to a -1, and then she'll go down to a -3. Very good job, okay? Who'd like to come up for the next one? Connor, come on up. Guys, where does he start?
Origin.
Origin. So he's going to go left and right first. He's not moving, and now he's going to go to -4, which is straight down. Fantastic. Final one. Pearson, come on up. We know we go left and right first, and then up or down. So she's going right to 1 and down to -5. Now what do I do, guys?
You put your line.
You just connect the dots. And we know that this can go on and on forever, so make sure you've got your arrows at the end. All right? And that is how you graph the function. Any questions about that? All right. This is going to be one of our tougher quizzes, so please, over the weekend, spend a little bit of time studying sections 7.5 through 7.8 for your quiz.